Okay, so there we go. So I've added my layer notation systems based on what we have on the board, A1, B2, C3, D4. Then I have to create basically the map. So we did this when we were doing cross-sectional drafting. You basically want to assign each warp and weft a pattern. And the only reason you're doing that is so you always throw in the same order, right? You're going to throw A, then B, then C, then D. And that's just going to help you when you're weaving keep track of things. So what I do here is I create a draft that's the size of the number of weft and warp systems that I have. And then I set A, B, C, D. Okay, so I'm saying I'm going to throw, I work from bottom up in my brain, so I'm going to throw A, then B, then C, then D. And every first warp is going to be system 1, second warp system 2, third warp system 3, fourth warp is system 4. So I have this kind of system space, and I can input it to the layer notation function, so it knows basically what the map is for what it needs to make. Okay, then I need to give each layer a structure. Because we're weaving on 8 shafts, we can only do 4 layers using tabby. If we used something like twill, we would have to do 4 times however many shafts you need for that twill. So that would be like more than we have, maybe 12. So we can go ahead and drag this tabby into each region. And as you're seeing, as I add each tabby, it adds it to the associated warp and weft systems. And then based on the layer information, it automatically adds the lifts that have to happen to keep one layer before another. Okay, so that's my draft. That's A, B, C, D. Now I want to make the next region. So the next region was A1, C2, B3, D4. Can anyone? C, B, D4. And then I regenerate it. And now, because I'm using the same structure on every layer, it's automatically done it for me. So now that draft is going to represent the next system. So what you would do, essentially, if you were going to weave this, you would say, I would probably import it into a rectangle that's the same number of pixels long that I want this region to be. Keeping in mind that this is only, since it's a 4-layer structure, this only stacks up to 2 pixels, right? Even though there's 8 layers, because they all stack on each other, you only get that little bit. So how many total pixels would you want? 20, great. So then you do 20 times 4. So that's going to be 80. And then we're going to make our width just the same. Conveniently, the width is 8. So you can read this exactly like a lift plan, right? So you can lift shafts, every shaft except shaft 8, and then throw, here, I'd read it from the bottom. That's just how I prefer to read it. You'd lift shaft 5, throw weft A. Lift shaft 1, 5, and 6, throw shaft B. So you would read this exactly like the lift plan. If you read it from bottom up or top down, you'll get the same thing. I just like reading it this way because that's the way I weave, right? Like my weave will stack on top of itself like this. Okay, so I weave 80 picks of that, and I probably want to weave 80 picks of this next structure too. If I wanted to actually join that into a long lift plan that I could just follow, probably what I would do is just print my lift plan for each section and label it, and then bring it out when I need it and weave as long as I want till I'm done. But if you wanted to do this the very official way, you could say join top, and you would say, okay, I'm going to weave this, and then I'm going to weave this. And it would just join them for you. Yeah.
So these two drafts that we've made are literally only like the first two.
Yes.
Okay.
Yeah, so how many drafts are we going to need total? So basically we've done these two, and there's 3 more. But are there more? Like, do we need to keep going?
Probably like 8 total.
I think so, yeah, because if we stopped here, I mean, if you stopped here and you cut it off, this is what you would see, and that would be fine. If you wanted it to actually like repeat, so that if you just followed the pattern forever and ever, it would always create a continuous lattice, then you have to keep doing this pattern of swaps until you get back to this layer order. So I don't think we'll have time to do that in class today, but do you want to just finish drafting out the rest of them? Okay, so what's this one? D3? Oh, I'm looking at the wrong one. Yeah. B4. Then this one is C1. And then I want to show you one other thing with this that's actually kind of fun. A3, B4. Okay. So one thing that's like, you can see these drafts and you're like, cool, I'm just going to trust that that's what's going on. If you want a little bit more intuition into what's going on, sometimes I just try to like give each one a different color. So I'll add a green, I'll add maybe a blue, and I'll add, who has a favorite color? Orange. Okay. Then I'll open this up and I'll actually give each one of those a color. Orange, blue, green. Okay, so now that color is actually going to like map onto the structure. And what you'll see is that based on what's lowered and lifted, you'll see some colors more than others, right? So in regions where the pink is dominant, we know that the pink is the top layer. Here, the pink is still dominant because pink is still on the top layer. But you actually see this a little bit better if we do it like this, join left. Even though this isn't how we're weaving it, it's just how I want to visualize it. Oh no, you're supposed to save the color patterns. Okay, I'm not going to do that. Okay, so let's copy this again. We'll do the next region, which was and so now you see a different color is on top.
I think it's B4.
Oh, yeah. No, I think it's C1, A2, D3, B4. Yeah. Oh, thank you. There we go. Cool. I copy this, I remove that, I put this in. And so now what color is dominant? Blue. So now you know whatever system is associated with blue is on top, right? So it's just kind of a way to visualize, even in all this madness, like basically you know the one that's on top has the fewest warp interlacements. And so that color is going to be most prominent. And then we would just continue this out. And I can save this file and share it if anybody wants to try it. But what's fun is that now, if you know that you have like 4 layer units that you can put in arbitrary orders, you can make all kinds of different like layer cross sections. So like you could also do right? Like, so that's a possible cross section. You could go 4 to 1, like that. You could, and then back to 4. So a lot of work in just kind of figuring out how many ways you can kind of arbitrarily join and unjoin 4 different lines. Yeah, and so here, it'd be A1, B2, C3, D4, all of them on one layer. Here, maybe it's A1, B2, C3, D4, and then you would have them all separate. Yeah. Okay, easy peasy. Go make lattices. The only problem, if you are gonna, can you do this on our? You could only do this on the 8 shaft that has a straight draw. So I think that's 8S, the one with the black and white. As Caleb experimented with 4 layers on that, you lose a lot of density. And so it does get very, it takes forever and it gets fiddly. So use thick wefts, ideally thick, flat wefts, right? Because then you'll get a lot more stacking. You'll get more bang for your buck that way. Yeah. You could even use paper, right? Actually, paper would be really beautiful on each layer. Cool. All right. Well, go forth and weave. I will save the screen recording. The last one I also put on YouTube. So I'll put this one on YouTube and then I can link to it from the class.